Greetings, this is Artie from Artifact Electronics. This episode will be part 2 of my Asteroids cocktail game from a thrift store restoration. What you're looking at is the original sales flyer. My buddy JP graciously donated this to the project, because generally when you're doing a restoration, it's nice. Sales materials are usually very helpful in seeing what it originally looked like. Problem with this is I think it's lying, because you can see that the body shows up in blue. Now, JP and I had an argument about this because he thought that these were just reflections when they took a picture of the cabinet and then cut and pasted it on top of the Asteroids background. But to me, I don't believe that, because if we look at the legs, they still show up as black. I mean, they're right here, and this shows up as blue. So my guess is that this was obviously a prototype and that they painted it blue. It doesn't really look that great, in my opinion. Sure, the blue matches with the little blue on the screen printing, but I personally think it looks a lot better in black. But if you have knowledge and or an opinion about this, please leave me a comment and let me know, especially if you've ever seen one of these in blue. I'm sure there is at least one old Atari engineer out there who's got one of these things sitting in his basement in blue. But anyway, today we'll be looking at monitor issues. One thing that I didn't mention was that this does not, it has a CRT obviously, but this is not a raster screen. This is an XY monitor or a vector monitor. And the difference is that a raster screen essentially scans all of the horizontal lines and prints out what's in a frame buffer. But what the XY monitor does is basically the CPU board says, gives it a position, an X and Y deflection, turns on the beam, moves the line across the screen, and then turns off the beam again. And for the time, it offered a financially feasible way to put a much higher resolution monitor into a video game, and giving you a better display than a black and white raster would have been in here. These monitors, they're kind of useless nowadays, because vector monitors, they were used many years ago, especially flight controllers and stuff had these little oscilloscope looking things that showed where all the planes were and so on. But nowadays there is, I mean, I'm thinking really hard, but there really is no need for vector monitors anymore, because you can simulate this on a high-res screen, which has been done, but it does look kind of clinical. It just looks too clean. The lines are too sharp. It's almost like the argument of digital audio versus analog audio. There's a certain number of imperfections you will see on the monitor that are difficult to replicate on a high-res raster monitor. Even though it's been tried, they go in and deliberately distort the lines and put extra noise in there and stuff like that. But there's nothing that is like a real vector monitor, which we'll see in a little bit. However, the problem is you can't get these things anymore. They're very difficult to find because they're completely obsolete. The tubes can probably be found, but the electronics can be found too, but people know what they have, and they charge you a whole hell of a lot for it. So let's go in and start working on the monitor. Here's an unadulterated view of the tube. The lines are pretty sharp, even though in the video they may show up as a bit washed out and out of focus, but that's because of the room lights I have here. The lines are actually sharp, but one defect I can see is that at the intersections of the test pattern over here, there is distortion. And this line particularly, you can see it curve. Also this one, these lines, the diagonal lines are not straight. If you look at the border lines, the vertical and horizontal lines, they're perfectly straight. The numbers are straight. And the little intensity gradient here is also straight, but there's something going on here. And that is generally due to old capacitors in here, depending on how old they are and how long it's been on. Now we can see this did some heavy duty, because if you look closely you can see that there's a light to moderate burn-in on the screen, and what the burn-in image is the high score screen, which it cycles in between. It cycles in between a demo and the high score screen, and if the thing was on 24/7, eventually the static high score screen will get burned in. The only way to fix that is to replace the CRT, but they're kind of hard to find and probably really expensive, so I'll probably make do with this one. Also keep in mind that the diffuser is removed. When you put the diffuser on, it mitigates the effect of the burn-in quite a bit. And then with that on and the glass on and everything, it's not really a big problem, especially if I turn up the intensity a little bit, because you can see it can probably use a little more intensity on the screen, and if I do that, because of the contrast, the burn-in won't be as obvious as it is now. So let's take it out of test mode. And if we look closely, we can see that those lines, those intersections that were distorting the picture, are also occurring here. Looking at this, of course you have to blow up, but if we look at options at this one, there's like a line. There's distortion happening when it hits those intersections. Any object that hits those intersections has distortion. So it should be interesting to see if a set of new capacitors is going to fix that. Here we have the monitor assembly removed from the game and put on the bench. And we can see, of course, here's the tube, neck board. Well, it doesn't really have a neck board actually. It just has a connector. This is the high voltage cage, and this is the screen driver cage over here. And the first and most important thing to do is to discharge the tube, especially since it was on a few minutes ago. It's holding a high charge. Now I don't know how well that's going to show up, but if we look over here, this is where the high voltage connection enters the tube. You can kind of see this brownish thing over here. And the way we discharge it is we basically clip the discharging onto ground and then slide the tip of it underneath the connection. And it's so it didn't even crack, didn't make any cracking noises. So to make sure, let's try another ground point also, something over here. Thus the tube is discharged, and we can now go ahead, remove all of the connectors, and then remove the PCBs, both this and this, and start the recapping procedure. Board removal was pretty painless. No desoldering required. It's got a nice harness with connectors on it, and everything just unplugs. And then the boards are screwed into the case, and removing a few screws frees the boards. Now what I did get is I ordered a cap replacement kit, which is everything you see from here to here, but what I got was it's actually a rebuild kit, which includes not only the smaller value electrolytics, but also the 4 driver transistors. And that's actually really nice, because looking at this, I looked at the boards when I took them out and checked them for new components, if anything had been replaced. And it didn't look to me like anything on either of these boards had ever been replaced by looking at the consistency of the solder and other telltale marks. So this thing doesn't look like it's ever had a part replaced. I might be wrong, but it sure looks original. So the monitor itself, if I haven't mentioned it, is an Electrohome G05 805 black and white XY monitor. And when I set up the case like this, I noticed that the tube, of course, which isn't made by Electrohome, is a GTE Sylvania, and it's of type 15ST4730R, part number 17-6152-05. And I'm guessing that this is a tube that was used in older black and white TVs also. It's a 15-inch tube. So what I want to do is do a search and see if I can maybe find an NOS replacement for this, or a cross-reference about what TVs actually use this tube and eventually swap tubes out. If you have any idea, or if you know of any TV that used these, please let me know in the comment section below. There were some more items I needed to do a good rebuild, in my opinion. And one was the two big caps over here, which weren't included, and that's most likely a price issue. These are 10,000 microfarad, 50 volts, and the temperature rating is 85 degrees. Well, actually, these are 85 degrees. I tried as I might, and I could not find a temperature rating on these. But taking the date of manufacture, late 70s, early 80s into account, I can be pretty sure that these are 85, that these are rated 85 degrees Celsius. So I think electrically these guys are exact replacements. The pins shape and spacing is a little bit different. If we look at the back of this, we can see that the caps currently mounted have this kind of pin spacing here, but they conveniently put in a third pin, which is shorted, to one of the two pins, to the positive pin over here. And if we look at these, which have the snap-on pins, but the spacing pretty much matches those two pins. So I can put these back in and make sure that they're mechanically flush with the board so that I get a secure connection over there. And other than that, the only other thing I figured would be nice to do is when I replace the caps, there are old insulators on here and dried heat transfer paste. So it'd probably be a good thing to replace the insulators. I mean, take these out. They are also solderless. There are sockets underneath them. Take them out, remove the insulators, clean up the old paste, put new paste on it, and put in the new transistors. And that should hopefully take care of everything that we just previously saw that was wrong with this monitor. Recapping went pretty well. All the parts were there, everything fit. The big guys you see over here, the two blue ones, it was a bit confusing because the originals were actually 3-terminal devices. Now, the middle terminal is marked as no connect, but on the PC board, one of them is the no connect is connected to the positive, and on the other one it's connected to the negative. So it was a little bit confusing to make sure that I got them in right. But as I said before, they fit flush. Removing these was a bit of a pain because the pads were rather large heat sinking things, and unfortunately I had to use one of these guys to get them out. But I don't think I broke anything. One mistake I made was I stated that all these caps looked to be original. That's not true. A few of these caps were labeled NTE. See if that shows up. NTE is a company in the United States that basically sells you all sorts of semiconductor replacements. They're all NTE marked. They sell you TTL chips and TV chips, transistors, everything. But they're all house marked. There's no way for you to trace where those come from. And generally they're of okay quality. The capacitors generally are not that good. The TTL chips, I mean, they're coming from one of the major manufacturers, so I've never had problems with those, because in a pinch NTE will save your life. But if you plan ahead like I usually don't, then you can get the real parts and don't end up with NTE replacements. Don't get me wrong, NTE is it's necessary for the marketplace and will save your ass once in a while, but I'm not so sure where all of their parts come from. Now, I did, for grins, I checked some of the caps, and almost all of the caps check good, except for these little guys here, which are, hello, 2.2 microfarads at, they're supposed to be at 50 volts. This one is an NTE replacement. It's at 160. And just for grins to see what the tester thinks this does. So you can see the value is correct, but the SR is pretty high. And all of these small caps displayed the same thing except one that was actually open. The other caps were okay, but we know that that doesn't necessarily mean a whole lot. So we got all new caps. And the other thing is, of course, the transistors. Here they are. The transistors all were original, date coded 1980. One change I made was I said I'm going to put new insulators in there. But the ones I had were kind of flimsy, and the ones I pulled out from here cleaned up nicely, were not cracked, stressed, or anything. So I cleaned them up and reused them. Keep in mind that you need to apply heat transfer paste to both sides of the insulator for it to work. If you don't apply it to both sides, it won't work too well. And what I think, I will do one final check on everything I did, and then we will put it back and have a look at the picture. I put the board back in, and sadly it made no difference at all. I'm sure the recapping was good, and there's no waviness or anything, but the two problems we saw before remain. And I should have kind of figured this out, because the two problems, first of all, if you look closely, you can still see that some of these straight lines are curving. That is not a digital phenomenon, but rather an analog phenomenon that I think is generated on the monitor or by the monitor, and can probably be fixed by adjusting the linearity controls on the TV chassis. However, the problem where the intersections of the lines are looking screwy, looks like chicken wire that's wrapping around each other over here, seems to be more of a digital nature, with the board possibly skipping vertical lines, or because see, this line comes over here and then it seems to jump to the left and move up a little bit, and I'm having a hard time wrapping my head around the actual problem. So nonetheless, we have to take the board out, and I want to do some general measurements on the board, check some pins on the ICs for stuck pins and such, and let's see what we can find out. I checked a whole bunch of stuff. My suspicion is in the area of the horizontal and or maybe the vertical counter chips, and operationally I couldn't find anything wrong. I had a scope on it, I had a probe on it. The scope said that the voltage levels were good. The probe said that there was activity on where there was supposed to be activity. Everything checked out fine, but as I was looking at this, I noticed something peculiar, and that is, let's see if I can show you this. For instance, if you look closely at these pins over here, or this one over here, these pins are all corroded. I mean, they look rusty to me. I checked the traces. The traces are clear. But whatever these pins were made of didn't like moisture or whatever was spilled on them. Now, there's no overspill here. There's something from the air contaminated them. And every single one of the horizontal and vertical counters have that corrosion on the pins on both sides. And the way I finally found it was that I had a really hard time probing those pins because they all returned nothing, and I had to press the probes pretty hard on those pins to get them to make contact and show me that they were working. Now, the corrosion can be cleaned up, of course, but what my worry is what I've seen a lot in cases where you have battery corrosion. Whatever causes this corrosion can travel inside the chip and weaken and stress the chip. My only way out here would be to take every single one of the corroded chips. I think I see about 10 of them, and all of them are concentrated in the vertical horizontal counter area, and replace them one by one. But that's going to be a very long exercise. And if I only had a single Asteroids board, then that's probably what I would do. But as luck would have it, I do have another Asteroids board in my collection that I fixed many years ago. The board was in pretty bad shape. Well, electrically it was in bad shape. I think I replaced 4 or 5 chips on it, but that board works correctly now. So I'm officially going to retire this board for now and install a newer board in the cabinet and see if that one works right and what the screen looks like. I put in the new CPU board, and it looks like the artifacting problem has disappeared. Everything moves smoothly with no discontinuities on the screen. So it definitely is a problem with that old board, and to me it looks like I'm going to have to go in and replace all of the chips with the corroded pins and see if that brings it back. Now if we switch into test mode, I did try to adjust the linearity. I was somewhat successful, but especially at this angle you can see that there's still curvature in the diagonal lines. I haven't found a procedure of how to do this properly, so what I did, I adjusted the width and height of the test this test display on the CPU board. You can adjust X and Y width separately, and made sure that I had the aspect ratio right. Because the X and Y circuits on the monitor board are identical, except that they have the Y voltages scaled, so you get a 5:4 aspect ratio on it. So the first thing I did was set up the frame so it showed the right aspect ratio. But then the problem was the linearity controls. There are 4 pots that were with a dab of glue on them, and the manual doesn't tell you how to do the adjustment. It basically says they're adjusted at the factory, don't mess with them. I did pull off all the globs of glue and did some adjustment, but I would adjust one and the others would go out of shape, and until I find the actual procedure for how to do the linearity adjustment, this is just going to have to do for now. I glued the pots back into place. I also glued the pots on the CPU board back into place so it maintains the aspect ratio. And it's not that noticeable in gameplay. It still bothers me, but right now I'm blindly turning pots and there's too many permutations. So I'll just wait till I come up with that procedure. But switching back to the game, it's hard to distinguish that the linearity isn't 100% on this. Everything looks okay. So far for the screen adjustments. Here's a quick look at the replacement board, the one that I had. Looks the same, of course, but several of the chips have been socketed and replaced, such as this one over here and some others. Here you can see the output pots to adjust width and height, and those were adjusted and glued down. Other than that, let me get some light into the monitor here. And if you can, it's kind of hard to see, but if you look closely, you can see the two pots to the right of the big blue caps are the X linearity, and the other ones are above that. Kind of hard to see, but yeah, there's 4 pots, and as I said, getting that into adjusting that by just wildly turning pots was not wildly successful. Here we can see the counter, which says 96,808 games played. So that's about all I will be doing for the monitor right now. While reviewing the last video of the screen, even though it looked really nice to the naked eye, I noticed how saturated all of the screen objects and lines were. So I put the diffuser back on, and this is probably a much more representative view of what the monitor looks like. It does actually look better than before the recap job, and so it wasn't all for naught. Well, it had to be recapped anyway, but it would have been nice. It's always nice to see at least a little bit of difference after you put in your effort. So we're done with the, we're done for now with the monitor. There are some scratches on the diffuser, so I'm probably going to get that replaced. But let's turn our attention to other outstanding issues. Okay, we've come to the end of part 2. There's still more to come, but here's basically all the parts I replaced in the monitor. And for good measure, I went in and replaced the electrolytics on the CPU board also. And we'll see the final results in the next part, where some other things are going to be taken care of. So make sure you click that symbol with the opposing thumb pointing up on the lower right of the video window. And if you haven't subscribed, go ahead and subscribe, so you can watch part number 3 coming up really soon as it's available. So we'll see you in part number 3.